Let's examine the testing procedure, beginning with a test sample fabricated from carbon steel. Here you see a certified welder constructing a 12 by 36 inch rectangular test sample. This is equivalent to a 24-inch round duct, a size often seen in hospitals, nursing homes, convention centers, prisons, and other medium to large service kitchens where life and safety issues are paramount. The steel is 16 gauge as prescribed, and the test duct is fabricated in accordance with the 2006 International Mechanical Code and constructed to the same criteria as test samples used at independent testing laboratories. This dimensional duct is very common where adequate ceiling height is not provided. This shows the duct being prepared for testing, properly supported, and being wrapped by independent certified insulation installers. 2 layers of 2-inch insulation are being applied to comply with the manufacturer's installation instructions. Weld pins are installed through the insulation and into the duct to secure it and prevent sagging. This system meets the requirements of AC 101, ASTM E2336. When properly installed and the joints are lapped, the outside dimension becomes 24 inches by 48 inches at the lap. A 24-inch round equivalent duct becomes 30 inches to 32 inches in diameter, depending on the manufacturer and the code requirements. Before testing, thermocouples are secured directly to the insulation using the same type pads used in factory-built system tests. The furnace is attached and fired at 500 degrees Fahrenheit until steady-state temperature is achieved on all thermocouples. This generally takes several hours. Upon reaching steady state, the temperature is rapidly increased to 2000 degrees and held for 30 minutes, during which time all 17 thermocouples are monitored. Average temperature cannot exceed 250 degrees above ambient. Any single reading that exceeds 325 degrees above ambient constitutes failure. Steady state was reached in 3 hours and 47 minutes. The burner fire rate was then increased to obtain the 2000 degree temperature requirement. 4 minutes into the high temperature portion of the test, at about 1700 degrees, the rectangular duct began to collapse. Notice the insulation on top of the duct starting to sag, indicating duct collapse within the wrap. 8 minutes into the test, with 2 of 4 thermocouples measuring input temperatures above 2000 degrees, collapsing of the duct becomes even more apparent, and fire from the furnace began to erupt to the outside of the duct through the void left by the collapse. Then the collapse increased along the horizontal length of the duct. 12 minutes into the test, we were not able to maintain 2000 degrees on any thermocouple measuring input temperatures. Catastrophic failure was obvious. The vertical section of the duct began to lean, and for safety purposes, the test was terminated. Our attempt to obtain data for an accurate ASTM E2336 UL2221 comparison failed. We were surprised at the severity of duct deformation in such a short time. While the insulation remained in position as installed, this severe deformation has the potential to compromise penetrations through a fire-rated partition.